into lesson 2. Now, since you're here, you've probably heard of Bitcoin before. Bitcoin was one of the first protocols to use this revolutionary technology called blockchain. The Bitcoin white paper was created by the pseudo-anonymous Satoshi Nakamoto, and it outlined how Bitcoin could make peer-to-peer transactions in a decentralized network. This network was powered by cryptography and decentrality, and it allowed people to engage in censorship-resistant finance in a decentralized manner. Due to its features, which we'll talk about in a little bit, people took to this as a superior digital store of value, a better store of value over something like gold, for example. And that's why you'll also hear people commonly refer to it as a digital gold. Similar to gold, there's a scarce amount or a set amount of Bitcoin available on the planet, only so much that you can buy and sell. You can read more about the original vision in the white paper. We have a link to the white paper in the GitHub repo associated with this course. Now, this was an insane breakthrough. And in a little bit, we're going to learn exactly how this is all possible and how this actually works under the hood. Some people, though, saw this technology and wanted to take it a little bit farther and do even more with this blockchain technology. And a few years later, a man named Vitalik Buterin released a white paper for a new protocol named Ethereum, which used this same blockchain infrastructure with an additional feature. And in 2015, him and a number of other co-founders released the project Ethereum, where people could not only make decentralized transactions, but decentralized agreements, decentralized organizations, and all these other ways to interact with each other without a centralized intermediary or centralized governing force. Basically, their idea was to take this thing that made Bitcoin so great and add decentralized agreements to it, or smart contracts. And in fact, technically, these smart contracts weren't even really a new idea. Back in 1994, a man named Nick Szabo had actually originally come up with the idea. Smart contracts are a set of instructions executed in a decentralized autonomous way without the need for a third party or centralized body to run them. And they come to life on these blockchains or these smart contract platforms like Ethereum. And it's these smart contracts that are going to be the core thing that we're going to be working on in this course and that we're going to be developing. You can think of smart contracts in the same way you think of traditional contracts or traditional agreements. They're just a set of instructions between parties. Except instead of written on pen and paper or typed up in Microsoft Word, they are written in code and embodied on these decentralized blockchain platforms. And that's also where they're executed, instead of being executed by the 2 parties or 3 parties or however many parties that are involved. This removes this centralized issue that we'll talk about more in a bit. This is one of the main differentiators between the Ethereum protocol and the Bitcoin protocol. It's these smart contracts. Now, technically, Bitcoin does have smart contracts, but they're intentionally Turing incomplete, which means they don't have all the functionality that a programming language would give them. This was an intentional move by Bitcoin developers. Bitcoin developers viewed Bitcoin as a store of value, versus Ethereum developers viewed Ethereum as both a store of value and a utility to facilitate these decentralized agreements. Now, these smart contracts on blockchains alone are absolutely incredible. However, they do come with a huge issue. If we want these digital agreements to replace the agreements in our everyday lives, they probably are going to need data from the real world. Blockchains by themselves actually can't interact with and can't read or listen to data from the real world. This is what's known as the Oracle problem. These blockchains are deterministic systems, and they're deterministic on purpose. And we'll learn more about how that works in the sessions to come. So everything that happens with them happens in their little world. But if they're going to be these agreements, they need external data and they need external computation. And this is where oracles come into play. Oracles are any device that delivers data to these decentralized blockchain or runs external computation. However, if we want our applications to stay truly decentralized, we can't work with a single oracle or a single data provider or a single source that's running these external computations. So we need a decentralized Oracle network similar to our decentralized blockchain network. Your on-chain logic will be decentralized, but you also need your off-chain data and computation to be decentralized. Combining this on-chain decentralized logic with this off-chain decentralized data and decentralized computation gives rise to something called hybrid smart contracts. And most of the biggest protocols that we interact with today are some type of hybrid smart contract, or interact with hybrid smart contracts to some extent. This is where the protocol Chainlink comes into play. It is a modular, decentralized Oracle network that can both bring external data and external computation into our smart contracts to make sure they're decentralized end to end while giving them the feature richness that we need for our agreements. Chainlink allows for us to get data, do upkeeps, get random numbers, or really customize our smart contracts in any meaningful way. Now, throughout the course, we're going to use the terminology smart contract. However, whenever we say smart contract, we're often using it a little interchangeably with hybrid smart contracts. But just know that when we say hybrid smart contract, we're talking specifically about smart contracts that have some type of off-chain component. Now, since Ethereum's release, a number of different blockchains or smart contract platforms have come to light, such as Avalanche, Polygon, Phantom, Harmony, and more. For the majority of this course, we're going to be assuming that we're going to be deploying to the Ethereum network. However, everything that we learn here is going to be applicable to the vast majority of the blockchains out there, like Polygon, Avalanche, Phantom, Harmony, etc. And understanding everything from Ethereum fundamentals will give you the skills that you need to switch chains very easily with literally one line of code. So don't worry about learning a specific tool or with a specific chain, because most of them work together seamlessly. Now, there are a couple of smart contract platforms that don't use Solidity, but still learning the fundamentals here will make you much better at those as well. And Ethereum by far has the most value locked and is the most used blockchain and smart contract platform out there. You'll also hear those two terms used a little bit interchangeably as well. Sometimes I'll say smart contract platform, sometimes I'll say blockchain. They kind of mean the same thing. Obviously, blockchains could mean store of value and smart contract platform, but you get the idea. Similarly, Chainlink is the most popular and powerful decentralized Oracle network, is the one that we're going to be focusing on for this course as well. Chainlink is also blockchain agnostic, so it'll work on Ethereum, Avalanche, Polygon, Solana, Terra, or really any other blockchain out there. Now, throughout this course, you'll hear the term DApp, or decentralized protocol, or smart contract protocol, or decentralized application, and they all kind of mean the same thing. A decentralized application is usually the combination of many smart contracts. And when we get into Solidity, you'll see what a singular smart contract really looks like. And like I said, learning all these core fundamentals will make you a better Solidity and a better smart contract developer. You'll also hear the term Web3 a lot in this video and in the industry. Web3 is the idea that blockchains and smart contracts are the next iteration of the web. Web 1 being this permissionless open source world with static content. Web 2 being the permissioned web with dynamic content, but all the agreements and logic runs off of centralized servers where they control your information. And then Web 3 comes back to the permissionless web, but once again with dynamic content. And instead of centralized servers running your logic, decentralized networks run the logic, creating these censorship-resistant agreements that these smart contracts enable. It is also generally accompanied by the idea that the users own the protocols that they work with, and it's an ownership economy. You'll see what I mean later in this course. Now, we've talked a lot about the history and about the high level of these protocols and of these smart contracts and what they can do. But what do these smart contracts really mean? What is it when I say trust minimized agreements or unbreakable promises? What is the real value add of these smart contracts? Before we look under the hood and take a peek at how this all works from a technical standpoint, let's learn what all the value of this is. What is the purpose of us building all these technologies, of you taking this course? What problem does this technology solve? In my mind, a technology is really only as good as the problem that it solves. If it doesn't solve a problem, then why bother? Smart contracts, blockchain, Web3, cryptocurrencies, those are all just different words that encapsulate the idea of what we're doing in such a unique paradigm. I think the easiest way to sum up what these smart contracts do is that they create trust minimized agreements. And if you might be scratching your head to that, a much easier way to think about it is just they give rise to unbreakable promises. Yes, you heard that right. Unbreakable agreements and promises. Additionally, they give rise to speed, efficiency, and transparency, and a number of other things. I made a video pretty recently about exactly this. Let's dive in and take a listen to the purpose, the undeniable value of smart contracts. Cryptocurrencies fundamentally re-landscape markets and agreements as we know them. Unfortunately, you've probably only been bombarded with people screaming about NFTs and money. Now, some of the memes are fun, but let's forget the bullshit and get down to the essence of this space. If you're already in Web3, This is the video to send to your friends to explain why you're so excited about this space and explain why we're here. And then if you're not into crypto, you've come to the right place. And yes, there are fun memes and markets and there's some money stuff and there are all these things. But outside of all that, the purpose of blockchains relates to the age-old elementary school unbreakable promise, the pinky swear. Let's get froggy. Nearly everything you do in life is the result of an agreement or a contract. Your chair was the result of an agreement to buy and sell lumber, to assemble and sell the chair to a retailer on Amazon. Then you made an agreement to buy the chair for $40. The lights in your house are powered by electricity, which is an agreement from you and the electric company. You agree to pay them in return, they'll keep the lights on. The electricity that they generate is agreements between them and engineers who built turbines to generate the electricity. With insurance, you agree to pay some amount of money to them every month, and in return, they will do nothing. They'll cover your medical bills. Almost everything you do and everything you interact with is the result of some form of agreement or contract in some aspect. Now, agreements and contracts can feel kind of abstract and boring to really grasp onto. So to simplify, we can also refer to them as promises. When you get an oil change, they're promising that they will faithfully change your oil in exchange for money. When you put money in the bank, they promise to keep it safe in exchange for them to use your money to give out loans. When you buy a lottery ticket, the lottery promises to give you a fair chance at winning a ton of money in exchange for you buying the ticket. Whenever you make one of these agreements, in a way, you're asking them to pinky swear to not screw you over and to treat you fairly. But this doesn't always happen. Let's look at a real world example of someone breaking the pinky swear. Back in the 80s and 90s, McDonald's ran a promotion for people to win money by collecting McDonald's Monopoly game cards. The idea was simple. You buy McDonald's, and in return, you get a chance to win $1 million. You can imagine McDonald's literally going, "Hey everybody, I promise if you buy our McFood and McNuggets, we'll give you a fair chance of winning this money. Woo!"
But they ended up breaking this promise.
Instead of having a fair chance of winning, your chance was in fact zero. In the mid-90s, between $13 and $24 million went into the pockets of not people playing the game honestly, but a group of corrupt insiders who had rigged the game. Meaning that when you played the McDonald's Monopoly game, you were buying into a set of lies and promises that were 100% always going to be broken. And the thing is, it doesn't really matter if this was McDonald's fault or not. They were the ones making the promises that they ultimately could not keep. Another way you could think about it is that that's $24 million that they essentially stole from you and I. Now, if this system was deployed on a blockchain with something called a smart contract, it would have been impossible to defraud this $24 million due to smart contracts being immutable, decentralized, and transparent. But I'll get back to that in a minute. In all the agreements and contracts we make, imagine making a pinky swear with a 10-year-old and imagining how that agreement would hold up. "Hey buddy, could you please keep my money safe? You can play with it if you like, but just please have it when I come back." Immediately, you might get that worrying feeling in your chest that something might go wrong, that this 10-year-old might lose your money. You might be thinking, how could I trust them? Will they break their promise? And this feeling of, I can't breathe because of untrustworthy situations happens to us all the time. Can I trust this used car salesperson to give me a good car? Can I trust this tag that says machine washable, or will it make my shirt shrink? Will my insurance provider break their promise of covering my medical bills when I get hit by a bus?
When Patrick promises he'll go on a hike with me, will he actually?
Yes, Becca, I actually will. The issue with our current agreements and contracts is we have to trust the people who are making them to do the right thing. However, often, they're actually incentivized to not do the right thing. Insurance doesn't want to pay out money. Sometimes salespeople just want to get the shit off their shelves. And with my girlfriend, I promised to go on a hike, but I hate hikes. Where else has this happened? Now you might be thinking, okay, Patrick, this seems cool, but like, where has this actually affected me? Well, the McDonald's lottery that we just spoke about above. During the Great Depression, with the run of the banks promised to keep our money safe, and that when we went back to go get it, they would actually have the money there. And well and behold, there were times that they didn't have the money there. Just last year, Robinhood painted this amazing picture. Come use our application. We will give you access to the markets. We promise we will give you, a retail investor, a fair chance of interacting with the world of finance. Psych. But not this asset, this asset, this asset, or this asset. The 2008 financial crisis. Remember that? Shady deals behind closed doors combined with lies about financial product brought the world to its economic knees.
How are you f***ing us?
Hyperinflation in Zimbabwe. Hyperinflation in Brazil. Theranos. History is a relentless lesson of trustworthy entities being notorious promise breakers. And we finally have a way to fix it with smart contracts. Now, before I jump into smart contracts, a lot of people might be thinking, hey, cool and all. However, we have systems in place to protect against a lot of these things, which is true and which is great. And that is a very helpful step forward. But these systems often break. The ones in 2008 definitely didn't work. The ones with the Robinhood crisis definitely didn't work. And even if these systems apply and you go to court to try to work them out, maybe you're in court for years before you actually see a resolution. And by that time, what you needed the money for is long gone. So what is this technology? What is this tool that can fix this fundamental problem in our agreements today? This tool is smart contracts, and this tool is what the blockchain was built for. Now, I'm going to give you a quick overview of what a smart contract is. However, I'm leaving some links in the description for more in-depth explanations. But the basics of them is, a smart contract is an agreement, a contract, or a set of instructions deployed on a decentralized blockchain. And once the contract or set of instructions is deployed, it cannot be altered, it automatically executes, and everyone can see the terms of the agreement. The real basics of it is that the code is executed by a decentralized collective, like a group of people, but a group of people running a certain software. This means that no one person or entity can actually alter any of these agreements or change the terms of the arrangement. In these traditional agreements, whoever owns the contract, whoever owns the execution of the contract can flip a switch and say, we're not going to do that anymore. In smart contracts, in Web3, in blockchain, you no longer can do that. Typically, these smart contracts are on a decentralized blockchain and used in combination with a decentralized Oracle network to get the real-world assets and information. And if these words sound like I'm conjuring up a magic spell, well, again, check the links in the description if you want to learn more about the technical implications. If you're not a technical person and you're not interested in getting to the nitty-gritty, you can kind of think of it like HTTPS. I bet the vast majority of you don't even know what HTTPS stands for, and yet you use it every single day whenever you log onto the internet. So how does this fix the McDonald's?
Okay. Light work. This is fun. Okay. I'm scrupulous. Very careful. Just have to be scrupulous about it. Just have to be scrupulous about it. This sounds like light work. We just have to be scrupulous. Scrupulous about it. Okay, this sounds like light work. I just have to be scrupulous about it. Autocorrected by Grammarly. Looks good. Scrupulous? Scrupulous. Scrupulous. What's scrupulous? Change back to scrupulous? I'm not madness. You trying to sabotage me, bro? Wow. Okay. This sounds like light work. Sounds like lightweight. Just to be scrupulous about it. Sweet. Alright. What day did Luna crash? Oh god, it was convinced. Cool. That's too many damn tweets. says May 7th after UST depegged. I remember Friday the 13th, the date I remember just thinking about it makes my chest tight. And my second crypto cash this time moving into zero. I call trick question. I don't know. I don't know if it's on Mondays. That's a trick question. Okay. Google says May 7th after the USD.
lawsuits that are crushing community banks and credit unions nationwide. They were in such trouble. One size fits all. Those rules just don't work. And community banks and credit unions should be regulated the same way, and you have to really look at this. They should be regulated the same way with proviso for safety as in the past when they were vibrant and strong, but they shouldn't be regulated the same way as the large, complex financial institutions. And that's what happened, and they were being put out of business one by one. And they weren't lending. Since its passage in 2010, Dodd-Frank has dealt a huge blow to community banking. As a candidate, I pledged that we would rescue these community banks from Dodd-Frank, the disaster of Dodd-Frank.
USDC.
An update on USDC and Silicon Valley Bank. This is a time of heightened uncertainty for the USDC economy. We remain committed to clear and transparent communication. TLDR. While USDC can be used 24/7/365 on-chain, issuance and redemption is constrained by the working hours of the U.S. banking system. USDC liquidity operations will resume as normal when banks open on Monday morning in the United States. As a practical matter, our teams are well prepared to handle significant volume, built on the strong liquidity and reserve assets discussed below. As a regulated payment token, USDC will remain redeemable 1-for-1 with the US dollar. What just happened? Silicon Valley Bank, a venerable and trusted partner to the US innovation economy, has just suffered a classic bank run, much like those we saw during the financial crisis in 2008. Few traditional banks have sufficient liquidity to withstand such a run. SVB suffered significant losses, which led to a situation where they were forced to sell long-duration assets to meet redemption demand. The settlement period on these assets caused a short-term liquidity crunch, leading to the FDIC stepping in to administer the bank yesterday. SVB's fate is being decided this weekend by the FDIC, and it's our hope that they will find a solution that protects customers' assets 100%. What is the impact on the USDC reserve? USDC is 100% collateralized with a combination of cash and US Treasuries. Specifically, USDC is currently collateralized 77%, $32.4 billion, with US Treasury bills, with a 3-month or less maturation period, and 23%, $9.7 billion, with cash held at a variety of institutions, of which SVB is only one. U.S. Treasury bills are the most liquid assets in the world and are direct obligations of the U.S. government. These reserves are held in custody by BNY Mellon, and active liquidity and asset management is managed by BlackRock. Anyone can view the entire liquidity ladder down to the QZIP number on T-bills via the USDX ticker. The remaining 23%, $9.7 billion, is in cash. Last week, we took action to reduce bank risk and deposited $5.4 billion with BNY Mellon, one of the largest and most stable financial institutions in the world, known for the strength of their balance sheet and as a custodian. $3.3 billion of USDC's cash reserves remain with SVB. As of Thursday, we had initiated transfers of these funds to other banking partners. Though these transfers had not yet been settled as of close of business Friday, we remain confident in the FDIC's management of the SVB situation and stand ready to receive these funds. $1 billion of the USDC reserves is held with Customers Bank as the industry looks to expand their transaction settlement options, and Circle maintains transaction and settlement accounts for USDC with Signature Bank. Both are important banks to the digital asset industry. USDC has zero exposure to Silvergate. We had transferred out what were limited reserves to support transaction settlement with USDC prior to bank closure. What do we expect with SVB and the FDIC? We have reason to believe that under applicable FDIC policy, transfers initiated prior to a bank entering receivership would have otherwise been processed normally. In other words, the FDIC should allow transactions to settle in the ordinary course through the end of a bank's standard daily processing cycle until the FDIC takes control of the failed institution. We understand that the FDIC is currently determining the status of transactions initiated prior to the applicable receivership cutoff times, and it is possible that the transfers initiated on Thursday will be processed on Monday. Moreover, SVB has a strong franchise that is at the center of American entrepreneurship and technology industry growth. We are hopeful that the FDIC as receiver will seek a rapid purchase and assumption of a franchise as strong as SVB's to ensure all depositors are made whole. However, it is also possible that SVB may not return 100% and that any return might take some time, as the FDIC issues ES, i.e., receivership certificates and advanced dividends to deposit holders. In such a case, Circle, as required by law under stored value money transmission regulation, will stand behind USDC and cover any shortfall using corporate resources, involving external capital if necessary. Related blogs. Build on Circle. 2023 Outlook, Building the Developer Ecosystem Together. Sandra Persing, January 25, 2023. Circle shares 2023 roadmap on supporting developers looking to explore crypto utility and build Web3 services. Read story about 2023 Outlook, Building the Developer Ecosystem Together. Featured. At Davos, Circle put mission front and center. Josh Burek, January 23, 2023.
Mm. Excuse me. Like 75 minutes in. Concrete jungle. Nah, I can't say that. Siri, how many days ago was May 7th, 2022?
It was 309 days ago.
Oh, nine. Wow. Oh, wow. Alright, cool. So,
What do you mean the bank is out of money? Insolvent? You only have enough cash for the next 3 customers? Hey, wait a minute, just a second here. No, I don't have your money here. It's in Bill's house and Fred's house.
Hey, what the hell you doing with my money in your house, Fred?
affiliation. Someone affiliated. Arbitrage? I want to. I think we speak. No, there's nobody there. All right, let's get to the work.
McDonald's monopoly issue. In its traditional form, the lottery was executed behind closed doors. Somebody operated and owned the code and the contracts and the agreements that ran the lottery, and they had the power to alter it, and nobody other than the people internal on the lottery could audit this altering happening. Now, if the code for this lottery was deployed onto a blockchain, every time a hacker attempted to alter it, everyone would be notified. Not only that, but you couldn't even alter it because the terms of a smart contract cannot be altered once deployed. Combine that smart contract with a Chainlink VRF oracle to get a verifiably random number, and presto, you now have a perfectly decentralized, unalterable agreement that is impossible to hack, commit fraud, or manipulate. We have just saved the public between $13 million and $24 million just by fixing the issue of trust. How does this fix Robinhood? Well, the problem with Robinhood is already fixed, right? Again, the problem is that there's a centralized body that can flip a switch at any time and say, yeah, you can't access these markets anymore. We're breaking our promise of actually giving you access to the markets. This is already fixed with something called decentralized exchanges, and these exist today. One of these exchanges is one called Uniswap. You can swap ERC20 tokens, which are kind of the equivalent of stocks, but some aren't, some are. It's a little confusing. I won't get into that here either. But it doesn't have that centralized body that can flip a switch and ruin access to the markets. And had these investors been on a decentralized exchange, it would have saved them hundreds of millions of dollars. And it would have prevented fraudulent market manipulation. How does it fix one of the banks? With transparency built in and automated solvency checks, you can build a bank-like smart contract that has insolvency checks built in that make it impossible to get there. Insolvent means broke as Any agreement or any history lesson where there was a trust assumption that was broken, smart contracts can be applied to and should be applied to, especially in a time where big money runs, owns, and controls everything. We desperately need to move to a world where some self-interested centralized entity can't flip a switch and ruin people's access to the services that they need. We can move away from a world that is brand-based to a world that is math-based. Right now, if you interact with a service that you don't like or that they break their promise, the only thing you can do is walk down the street to the next service that's going to make the same set of promises, and you have to hope and pray that they're actually going to keep it. We can move from that to a world where we can just look at the math and say, oh, okay, 1 + 1 = 2. This is what this agreement is going to do for me every single time, guaranteed. Because it's a decentralized autonomous agent, has no incentive to be evil, and everything is transparent and out in the open. If I'm a big company, and if it was better for me for 1 + 1 = 3, maybe I would go behind some closed doors and fudge some numbers and come back out and be like, hey, 1 + 1 = 3. But with smart contracts, that's impossible. Doing the right thing is infrastructural. Now, given the choice between two agreements, One where you have to trust a single centralized entity that they're going to do the right thing for you, versus a decentralized, untamperable collective. Which one are you going to choose? I'm picking the one that can't screw me over every single time for every agreement I can apply it to. Now, this technology is relatively new, but we have already seen it re-landscape entire markets and continue to do so. The traditional financial world is already getting its lunch eaten by DeFi, or decentralized finance. There's already over $200 billion of people's money in these protocols to help have a more fair, more accountable, more transparent financial system. This DeFi movement is one of the main reasons I got into this space, because we desperately need to move away from where we are right now and end people's chances for wealth being sucked up by some group that's bending the rules in their favor. And smart contracts are our ticket to that better world. More and more industries are also coming over to smart contracts and blockchain because of all the innovations and because of all the advantages that it has. As we grow and as we get better, we get closer to this vision of having this concept fulfilled. Trust minimized agreements. These smart contracts are minimizing the trust that we need to give other people in order for these agreements to be executed. If trust minimized agreements is too confusing for you, just say unbreakable promises. Now, I gotta be honest with you guys. Blockchains and smart contracts and cryptocurrencies can actually do more than just trust minimized agreements. What? They have security benefits, uptime benefits, execution speed benefits, and a whole lot more. But it's a lot easier to just learn about one and learn the other ones later, right? It's kind of like sprinkles on top. So this is why we are here. This is why we're building this future. And this is why we are so excited about it. Whew. Even in just this introduction part, we've learned a ton. So let's do a quick summary of what we've learned so far. Bitcoin was the first protocol to take this blockchain technology into the limelight and take these cryptocurrencies into the mainstream. Bitcoin is a sort of digital gold, or a store of value, able to make transactions between users in a decentralized manner. Ethereum and other smart contract platforms take this blockchain technology one step further, enabling people to make smart contracts and decentralized trust minimized agreements. These smart contracts and decentralized applications can access and interact with the real world using something called decentralized Oracle networks. Chainlink is a decentralized network that allows us to build these hybrid smart contracts, which combines our on-chain logic with our off-chain decentralized data and decentralized computation, giving rise to our logic being completely decentralized and our data and external computation being completely decentralized, giving us all the features that traditional agreements and traditional contracts have. Now, these digital currencies like Ethereum and Bitcoin have value even without the smart contract part. Having a censorship-resistant, decentralized store of value is immeasurably powerful in its own right. We have some links in the GitHub repository that'll teach you how this decentralized store of value flips traditional finance on its head. And it's another one of the great reasons for building smart contracts. But again, the easiest way to boil it down is trust minimized agreements or unbreakable promises. But let's also go into some of these other features that smart contracts have over our traditional environment. The first feature, of course, is that they are decentralized and they have no centralized intermediary. The different individuals that run one of these blockchains are known as node operators. And it's the combination of all these thousands of node operators running the same software, running these algorithms, running these smart contracts that make the network decentralized. We'll dive deeper into how that works later. The next feature is transparency and flexibility. In these decentralized networks, since all these individual node operators run this software, everybody can see everything that's happening on chain, meaning there's no shady deals, there's no weird things happening. Anything that's going to be unfair, people would be able to see and just not use. Everybody has perfect information and has to play by the same rules. Now, additionally, this doesn't mean that there's no privacy. The blockchain is pseudo-anonymous, meaning that you aren't necessarily tied to an identity in real life. They also have the feature of speed and efficiency. For those of you who have ever tried to do a bank transfer or send money across seas, you know it sometimes can take 2 to 3 weeks, when in fact, all these banks are really doing is basic math. They're subtracting money from your balance and adding it to some other balance. Why does it take so long? In the blockchain, all of these transactions happen instantly. Another instance for those in the financial world today know that clearinghouses and settlement days can take a long time. In the blockchain, there's no need for any of that because they happen instantly. This obviously is much quicker, but it also makes for much more efficient interactions with each other. Security and immutability. Again, immutable means that it can't be changed. Once a smart contract is deployed, That's it. Whatever's in the code is going to be in the code forever. They cannot be altered or tampered with in any way. This means that the security is much easier. Whereas in a centralized world, somebody can hack into the server, jump into the database, and change some numbers. You can't do that in the blockchain world. And since it's decentralized, in order to hack the blockchain, you'd have to take over half of the nodes, as opposed to in the centralized world, where you only have to take over one. In the regular world, if your computer and your backup computer go down, all of your data is gone. In the blockchain world, if your computer and your backup computer go down, all your data is safe because it's being run on all these other decentralized nodes. And even if a few hundred nodes or if a few thousand nodes go down, it doesn't matter because as long as one node has a copy of the blockchain, you're good to go. Hacking a blockchain is nearly impossible and leaps and bounds more difficult than hacking a centralized server. Not only that, but this is safer in the asset sense as well. All you need to access your credentials and your information and your assets is your private key, which is basically your password for all of this. And as we've discussed in the video, these smart contracts remove this counterparty risk, remove this centralized intermediary, remove these trust gateways that we have to do in Web 2. When we engage with users and individuals, they don't always have our best interests at heart. Smart contracts remove this counterparty risk because once one of these contracts is created, they can't go in and they can't alter it, and they can't let greed or ego or anything else get the better of them and alter the terms of the deal. And as we said, this gives rise to these trust minimized agreements, or these programmatic unbreakable promises. We move away from brand-based agreements to math-based agreements, where we can look at the cryptography, we can look right at the code and see exactly what something is going to do and how it's going to execute, versus having to rely on a human being doing the right thing. With smart contracts and decentralized hybrid smart contracts, doing the right thing is infrastructural. All these pieces boil down to us having the freedom to interact the way we want to interact without having to be afraid that interacting like that is going to screw us over. This trust minimized piece, these unbreakable promises, make interactions so much better. In the purely Web 2 world, we're constantly bombarded with messages of projects and protocols pushing us to move or act in the direction that makes them more profitable. Versus in the smart contract space, we can see everything transparently, and we can even engage and interact and be partially owners of the protocols and the interactions that we decide that we want to code. Now that we're getting to the coding sections, I need to stress to absolutely use the GitHub repository associated with this course. If you come to the GitHub repo and you scroll down and you click the lesson that we're on, right now we're on lesson 2, Welcome to Remix, Simple Storage. If you click on it, it'll give you a ton of timestamps and other helpful links associated with this lesson. Additionally, the biggest piece is that all the code will be available right underneath the lesson title. This will have all the code that we're going to be working with, as well as some more additional information on how to work with the code. Please, when asking questions and entering in discussions though, please ask your questions in the full Blockchain Solidity course repository. Thank you. And if we're at the top of the repository and we scroll down, we have this resources for this course section, which brings us to the GitHub discussions, which you can ask questions in the GitHub discussion section of this course. Additionally, on Stack Exchange Ethereum or Stack Overflow. I'll talk a little bit about how to format questions and ask questions the best way so that you have the highest chance of getting a good answer in a later lesson. I highly recommend you pause and make accounts for Stack Exchange Ethereum, Stack Overflow, and GitHub right now if you haven't already. Links to them, of course, can be found in our GitHub repository. Typically, for each coding section, I'll start it off by giving a quick overview of the code of what we're going to be working with and what we're going to be building towards, since everything that we're doing is going to be project-based, and that's how we're going to learn. For our first one in Remix, though, we're going to skip over that because there's a lot of stuff to get used to. Now, I highly recommend that as I'm coding this and as I'm doing all this in Remix, you follow along with me and you code along with me. Remember, you can change my speed if I'm coding too fast or if I'm coding too slow. To start, we're going to jump into a tool called Remix. If you're unsure how to get there, there's a link to Remix in our GitHub repository. This is where we're going to be writing all of our code. So welcome to the Remix IDE, or Integrated Development Environment. This is where we're going to learn how to code and interact with our smart contracts. If you want, you can go ahead and accept to help out Remix. If you've never been here before, it'll give you a quick walkthrough of some of the tools that Remix actually has. We're going to skip over them for now because I'm going to explain everything that's going on. Remix is such a powerful tool because it has a lot of features that allow us to really see and interact with our smart contracts. Eventually, we're going to move off of Remix actually to a local development environment. However, Remix is absolutely fantastic for learning the fundamentals of Solidity, and I highly recommend everybody start with Remix when they're getting started. When you come to the Remix IDE, there's a whole lot of different things that are popping out to us. There's a lot of different plugins as well. Since we're going to be working with Solidity, which is going to be the language that we're using to develop our smart contracts, we can go ahead and get started by clicking the Solidity plugin. And a couple of other tools will show up on the side. Even if you don't click the Solidity plugin, you'll still be able to code Solidity smart contracts. The left-hand side is where we're going to start to actually interact with things. The button on the topmost of the left is our files or Explorer directories. Remix comes boilerplated with some different contracts, some different scripts, some different tests, and different dependencies. We are going to minimize this a little bit. So if you want to go ahead and right click and delete some of these folders, other than the contracts folders, feel free to do so. Or if you kind of like them there, feel free to leave them as well. We're going to leave our contracts folder and we're going to delete the different files inside of it just so that we can start from a blank slate. Most projects come with something known as a README. Usually it's a readme.md, which usually explains how to actually work with code. But for our purposes, we're going to delete this as well, and you can just follow along with me. Now we have a blank remix setup. Click on the contracts folder and click the little page icon to create a new file. A little box will pop up and you can start typing text into it. We're going to type in simple storage.sol. .sol tells our compilers that this is going to be a Solidity file and that we're going to code Solidity in this. Solidity is the primary coding language of smart contracts. There are a few other smart contract languages as well, but Solidity by far is the most dominant smart contract coding language out there. And now we have a simple storage.sol contract on the right that we can actually start coding our Solidity with. So let's start coding some Solidity. Now, if you click on this button right below the Files button, that looks like the Solidity logo, you'll see a bunch of stuff pop up in here. These are different parameters for us to actually compile our Solidity code so that we can run it. So the first thing that you're going to need in any Solidity smart contract is going to be the version of Solidity that you're going to use. And this should always be at the top of your Solidity code. Solidity is a constantly changing language and a constantly updating language because it's relatively new compared to other languages. We need to tell our code, hey, this is the version that I want you to use. We can add the Solidity version by doing pragma Solidity and then the version that we want to use. If we want to choose a very specific version, we could say 0.8.7. The most current version to date is 0.8.12, but getting used to different versions of Solidity is good practice. And different versions of Solidity are considered more stable than others. 0.8.7 is one of those versions that is considered more stable. These double slashes here are what's known as a comment. They're places where you can type stuff that won't actually get executed and won't get compiled and isn't really considered part of your code. For example, I could write, hello all, I'm Patrick. And if we were going to run this code, this part of my code would get completely ignored. So this double backslash is how we do what's called comments. And as we're coding and as we're building our projects, be sure to use this comments tool to your advantage. Every time you write a new function or you learn something that you didn't understand or you learn something new that you want to remember, put it in a comment in your code. You're going to be most effective at taking notes in this course by making them comments in your code and then saving your code so you can refer back to it later. So leave comments in your code, leave notes in your code, and that'll be one of the best ways for you to understand what you're coding when you want to refer back to it later. Now, when it comes to the versions of Solidity, there's actually a few different ways we can actually write it. We can say we want to use only 0.8.7, and this is how we would write that. But maybe we're okay if we use a more new version of Solidity than 0.8.7. To tell our code that we're okay with a more new version, we can put a little caret here. And this is how we tell Solidity, hey, any version of 0.8.7 and above is okay for this contract. This means 0.8.8 would work, 0.8.9, 0.8.10, etc. But if understand more and more of what good names for parameters are. Every time we call this store function, see the little green check mark. That little green check mark means that our code is compiling successfully and we don't have any errors. We could hypothetically deploy this contract right now and it would be a valid contract. So congratulations on writing your first contract. Now Solidity has multiple different types or primitive data types. And if you go to the Solidity documentation, which again is in our GitHub repository, you can read more and learn more about the different types that are in here. Be at the top of your Solidity code. Solidity is a constantly changing language and a constantly updating language in that all your code. Open and close little open and close curly brackets. Everything inside this open and close curly brackets is going to be the contents of this contract simple storage. Now, if we go ahead and hit Command S or Control S, we can see this little green check mark show up. And if you don't, you can always go back to the compiler tab, scroll down and hit compile and see the little green check mark. That little green check mark means that our code is compiling successfully and we don't have any errors. We could hypothetically deploy this contract right now and it would be a valid contract. So congratulations on writing your first contract. Now Solidity has multiple different types or primitive data types. And if you go to the Solidity documentation, which again is in our GitHub repository, you can read more and learn more about the different types that are in here. The four most basic types are going to be Boolean, uint, int, and an address, or bytes, which is a lower level type, which we'll talk about a little bit later. A Boolean defines some type of true false. A uint is going to be an unsigned integer, which means it's going to be a whole number that isn't positive or negative, it's just positive. We have an integer, which is going to be a positive or negative whole number. And then we have an address, which is going to be an address, like what we see in our MetaMask here. There are some other types as well that you'll learn later on. The reason that we have these types is we use them to define what different variables are. Variables are basically holders for different values. For example, we could create a variable called has favorite number to represent if somebody has a favorite number. And we would put this bool keyword before has favorite number to say, okay, we have a variable called has favorite number and it's of type Boolean. So this has favorite number is going to represent a true or a false. To set its value, we could say has favorite number equals true. Now has favorite number is going to be true. We could also say has favorite number equals false. So this Boolean has favorite number is now going to be false. For uints, we could say uint favorite number equals and then set a number 1, 2, 3. This means that our favorite number is going to be 1, 2, 3. Uint is special because we can actually specify how many bits we want to allocate to this number. Bits and bytes are pretty fundamental pieces of information for computer science. We're not going to go over it here. However, there's a fantastic video in the GitHub repository that explains it more. Basically, it's how much storage or memory to allocate to this number. How big can it get? If we say a uint 8, it can have 8 bits all the way up to uint 256. If you don't specify how big it is, it automatically defaults to uint 256. Oftentimes, it's better when writing our code to be very explicit. So usually you'll see me just do uint 256 to represent a uint 256. We could also do an int favorite number equals 1, 2, 3, or an int 256. I'm just going to go ahead and add this Boolean back here. We're going to change this back to uint 256. And let's change our favorite number to 5 here. We could also do something called strings. String favorite number in text equals 5. Strings represent basically words, and you can represent them by putting them in these quotes. It's going to be some word or phrase or really just kind of any combination of keystrokes in here. Our ints can be positive or negative. So we could say -5 or +5. Both are going to be valid ints. We can also do address. My address equals, and grab our address right from MetaMask and paste it in. You'll notice that we end all of these lines of code with these semicolon. We can also have bytes objects or a bytes 32, again, representing how many bytes we want them to be. And this says that we have called favorite bytes, and we're just going to set it equal to cat. So strings are actually really interesting because strings are secretly just bytes objects, but only for text. So cat is actually a string, but can automatically get converted into one of these bytes objects. Bytes objects typically look like 0x and then some random letters and numbers that represent the bytes object. But cat cat can automatically get converted down.
That's crazy. I didn't know it would be a tooth. That's very interesting.